Hi, CP Algebra 1. This is number 3 from Solving Linear Equations, SLE number 3. So go ahead and take notes on this with the notes provided for you. And here we go. All right, so cell phone bill, $59.40. What is the monthly service charge? It's $30. If your plan costs 7 cents per minute, how many minutes did you talk on the phone this month? Okay, so we need to look at this saying, okay, this 30 I'm going to pay every month no matter what. Okay, but I'm going to charge, it's going to charge me 7 cents every minute I talk. Okay, so 0.07 times every minute I talk, plus the 30 that would add to it would give you the what your bill would be. But then they tell us that their bill actually comes out to $59.40. $59.40. So we're going to go ahead and solve this. Now, I know cell phone plans aren't like this. This is how they have been. So we're not necessarily, we're doing a little bit of real life, but life has changed a little bit. So let's focus on how we would solve this problem. So I called M for minute. I could have called it X or any other variable. But let's go ahead and solve this. So on this particular problem, remember, if we kind of do the equal sign as that dotted line all the way down, if I subtract 30 from both sides, excuse me, so I get 0.07m is equal to $29.40 if we go ahead and do that math. And then I need to actually bring out my calculator because I'm going to go ahead and divide each side by m. So let me pause the video for a moment. Okay, so what we're going to do is 0.07m is being multiplied times m, so I need to divide it to undo it. So those cancel out, but make sure you do it on this side as well. So using a calculator, you're going to go 29.4 divided by m. So I'm going to switch over to a calculator page. So I'm going to go 2940, 29.40 divided by the 0.07. If I divide that by 0.07, it looks like we talk on our phone on that particular month for 420 minutes. 420 minutes. A minute equals 420 minutes. That's how much time you spent on your cell phone. Okay, so take a look at that. If you have questions, make sure you ask during class, and we will go over this kind of idea. But this is just a warm-up to what we're going to start working on. Okay, so remember, to solve an equation, our goal is to get the variable. The variable is the letter alone. Okay, get the letter alone, the variable. So it's like a big balancing act. So you remember, if I were to put, a little bit on this side and I'd have to do a little bit on this side for it to stay balanced. So if I bring this all straight down, that's my equal sign. So it's balanced on each side. So let's go ahead and work out this next problem. So again, remember this is like a balancing act. I'm going to bring down this vertical line. I have to pick on this particular problem. Where do I want x? Doesn't really matter. Doesn't really matter where you start this problem. So I might choose, because I have x on both sides, I'm going to subtract the smaller of the x values from either side. Those cancel. That leaves me 3 on the left side. And on the right side, 8x subtract 6x is 2x. Subtract 21. And then, again, I want to start getting my variable alone. And it's okay right now if the variable is on the right side. I'm going to go ahead and add 21 to both sides now. Those cancel. And those combine. That gives me 24. So 24 is equal to 2x. 2 and x are being held together by multiplication. So I wind up with 12 is equal to x. And of course, please flip it over. It's more accepted to have x equals on the other side versus 12 equals x. So x equals 12 is more. It's not wrong if you have 12 equals x, but it's more preferred to have it the other way. All right, so next problem, we're going to go ahead and bring this down. So this is a 1d, right? So I'm going to subtract 1d from both sides. And that's going to give me negative 7d on the left, because negative 6 minus 1 is negative 7. And that equals 4. Divide each side by negative 7. These cancel each other out. So I wind up with d is equal to 4 over negative 7. Now I know that I could have written that this way. I could have written it this way. Or I could have written it this way. So any one of those answers is totally fine. So you just pick which one you feel the most comfortable leaving your answer as. Okay, a single negative sign would keep the problem negative. All right, let's go ahead and take a look at the next problem. I'm going to bring this straight down, just like we've been doing. I'm going to subtract m from both sides. So those cancel. So I get negative 5 is equal to 3 minus 1 is 2, so I get 2m. And 2 and m are being held together by multiplication, so I'm going to divide both sides by 2. So I wind up getting negative 5 over 2 is equal to m, because those cancel out. Again, flip it over and get the variable on the left side. Just flip, no signs change or anything like that. Just flip the whole problem over. Again, that's the more acceptable way. Number 4, again, we're going to do our equal sign all the way down as the dashed line. We're going to choose, let's move the k on both sides, so I'll move the smaller k over. So these cancel each other out. 7 minus 5 is 2, so I get 2k. The minus 4 comes down, equals 16. And then from there, I'm going to go ahead and add 4 to both sides of the equal sign. So those cancel each other out. So I get 2k is equal to 16 added to 4 is going to give me 20. Well, 2 and k are being held together by multiplication, so I'm going to divide each side by 2. Those cancel. So I get k is equal to 10. Again, if you have any questions on these, let's talk about them when we're in class, and we will go from there. Then problem number 5. Again, that's going to be my equal sign. And I'm just using that as a guide right now. We'll eventually get to a point where we won't worry about having the dashed line all the way down. You certainly don't need to have it if you don't want it. But what would we do to both sides? Well, let's start this one a little different. Rather than moving the letter, let's move one of the numbers. So I'm going to subtract 10 from both sides. See what happens. Those cancel. So I get negative 8a is equal to 5 minus 10, which is negative 5, minus 4a. Remember, 5 minus 10 is a negative number. Okay, now I want to get a by itself, so now I'm going to add a to both sides. So negative 8 added to 4, something costs $8. You have $4 in your pocket, so you still owe $4, so it's negative, equals negative 5. And then from there, negative 4 and a are being held together by multiplication, so I'm going to divide each side by 4. Those both cancel out, so I get a equals. I have a negative over negative, so my answer is going to be positive, so I don't have to put a positive sign. I can, it's not necessary, but my answer is 5 over 4. And again, leave it as an improper fraction, meaning the top is bigger than the bottom. Make sure it's reduced. So problem number 6, it looks like I have 2 of the same variable on the right side of the problem. I have these on the same side, so I'm going to combine those before I move anything around. So I get negative 6m is equal to 7m minus 1m is 6m plus 7. And then let's go ahead and subtract our m from our 6m from both sides. So those cancel out and those cancel out, and lo and behold, I wind up with something that you know this can't happen. That's just a completely awkward scenario. That's not true at all. We all know that negative 5 is not equal to 7. So if all the variables fall out and something becomes a false statement, that means we have no solution. There's no numbers that we can plug in for our variable to make this problem work. If you had this problem, and let's say it came out to be 7 equals 7, where all the variables dropped out, where this becomes true, this means we have infinite solutions. That means that any number we plug in gives us the correct number out. Okay? So if you had a true statement with all the variables or all the letters falling out, that means that you have a true statement. That means there's infinite solutions. If you wind up with a false statement, that means we have no solution. There's nothing I can plug in to make it work. And that's it. Make sure you take a look at the homework that's suggested for you. It's in your workbook. If you don't have it on the workbook, it is underneath this video and notes for today. Have a great day, everybody. Take care of one another.